Okay, our exit ticket for today was to go ahead and find the reaction product for an addition reaction with 2,3-dibromohexane. And here's the question. We need to deduce the full structural formula for the organic reactant. So let's take a look at our givens. We know that an addition reaction means that we have an alkene going to an alkane. And this one, since it's dibromo, that means that we have a haloalkane. And this is telling us that the product is this 2,3-dibromohexane. And we know that addition reactions only have one product, so I don't have to worry about anything else here. So I have something plus something forms just this one product of 2,3-dibromohexane. So I know that one of my reactants comes from this part right here, dibromo. Bromo standing for bromine. And the fact that there's two of them makes a lot of sense because bromine is a diatomic molecule when it's on its own, so there has to be two of them bonded there. Okay, so we're looking for this final, or this initial reactant. We want the full structural formula of that reactant. So we're going to start out by drawing the full structural formula of the 2,3-dibromohexane. That's going to help us visualize what's going on here. So I'm going to have hex, meaning 6, ane, meaning that they are all singly bonded, and then that 2,3-dibromo means that I have a bromine on carbons 2 and 3. So we're going to start drawing this out. 1, 2, 3, 4, 5, 6. And here is my second carbon, so I'm going to put a bromine on that one. Here's my third carbon, so I'll put a bromine on that one. Then I have to add all of those other hydrogens that I need. And we can see here and think about addition reactions. If the Br2 was initially together, that means that when we're going back to the reactants, those were not there. So if we're kind of thinking about an intermediary, something that's in between the initial and the final reaction, we have a CH3 on the end, followed by a CH2 or CH. Both of those are radicals. Oops. Radical. And then we have the CH2 and a CH3 at the end. So again, this is kind of an intermediary. This is what happens in between when those Br2s, which are Br, break apart. So we have a Br radical and a Br radical, and then they end up reacting with those two open spots. So if we're thinking about where we got it from originally, we can say, well, if those are radicals right there, then what must have been is a double bond had been broken. So let's draw out what my actual structure is. Okay, that would have been what initially started out, that then formed this intermediary when the double bond broke, formed a radical of hexane, and then the bromines broke apart to form radicals, and then we ended up getting that final product. So again, the question was asking us for the full structural formula for the organic reactant. So this right here is my answer. If it had asked for a condensed structural formula, we would have taken out all of those bonds, and we would say CH3, CH is repeated twice, and then CH2 is also repeated twice, and then we would end with a CH3. If it had asked me for a line angle diagram, then I would say each ending of a line is a carbon with its subsequent hydrogens. We go up to my second carbon. Between my second and my third is a double bond. Then we have my fourth carbon, fifth carbon, sixth carbon. And if we were asked to name this, we know that 1, 2, 3, 4, 5, and 6 is a hex. We know that a double bond is an ENE, so we have hexene. And we know that that starts on the second carbon, so it's 2-hexene.